Okay, so today's lesson is going to be on matrices, and it's starting from the very beginning of matrices. So what a matrix is and then how to add and subtract them. So in maths, a matrix is a rectangular array of numbers, symbols or expressions, and they're arranged in rows and columns. So that's what the actual object is. It has matrices have a lot of uses once you get into more advanced maths. At this level, you're not really going to use it for anything. You're just going to learn what they are, what they look like, and how to manipulate them in basic ways, like adding and subtracting, multiplying by a scalar, multiplying them together. If you go on to do maths at university, you would use them for things like graph theory, analysis and geometry. They can be used for solving systems of equations, and they're also used in computing. So a lot of the video games you play, for example, will have matrices in their coding. You actually have already seen a matrix in normal maths. Vectors are matrices. They have 2 rows and 1 column. So this is a description of what a matrix is. If you want to write that down, and then I'll move on to the next bit. An important part of a matrix is its dimension. We say that a matrix is m by n. If it has m rows and n columns. Additionally, there's 2 special types of matrix that you need to know. There's a zero matrix. We never say the zero matrix or the identity matrix because there are loads of them, because they can vary in size. So a zero matrix is a matrix where all entries are 0. So some examples: you could have a 2 by 2 zero matrix. You could have a 3 by 4 zero matrix. It has 3 rows and 4 columns. So this is a 3 by 4 zero matrix. So both of these are 0 matrices. So we can't have the zero matrix, but they are 0 matrices because they have all entries 0. So that's an important type of matrix, the 0 matrix. This type of matrix is equivalent to the number 0 in matrices world. Another important type of matrix is the identity matrix. So an identity matrix is a square matrix. It can only be square. So a 0 matrix can be rectangular, but an identity matrix can only be square, so it has to have the same number of rows as columns. So an identity matrix is a square matrix where the leading diagonal is filled with 1s and every other entry is 0. Oops, can't spell other. So copy that definition down, please. Pause the video to do so, and then I'll explain what exactly that means. So an identity matrix is a square matrix where the leading diagonal is filled with 1s and every other entry is 0. What does that mean? Leading diagonal means we start in the top left and working diagonally, each entry is 1. Every other entry is 0, and because it's an identity matrix, it has to have the same number of rows as columns. So this is a 3 by 3 identity matrix. This is a 5 by 5 identity matrix because the leading diagonal, so starting in the top left and then working diagonally to the bottom right, are all 1s and the rest of the entries are 0. So this is a 5 by 5 identity matrix. The identity matrix, an identity matrix, is similar to the number 1 but living in the world of matrices instead. If two matrices have the same number of rows as each other and the same number of columns as each other, we can add them together or we can subtract one from the other. So we can add an m by n matrix to any other m by n matrix. We can also subtract them from each other. However, you cannot add two matrices together if they have different numbers of rows or different numbers of columns. So we could add a 3 by 2 to a 3 by 2, but we could not add a 3 by 2 to a 5 by 6. An example then of adding two matrices together, it's very, very intuitive. All you do is add entry by entry. So if I want to add these two matrices together, this is a 3 by 2 matrix. This is a 3 by 2 matrix. So we can add them together because they have the same number of rows and the same number of columns. And the way I'm going to add them together is just by adding corresponding entries. So this 6 is the top left entry of this matrix. This 2 is the top left entry of this matrix. So I add those two together. That's my first entry. This 3 and this 8 are both top right, so I add them together. This 2 and this 11 are both the first numbers in the second row, so I add them together. Add these together, add these together, and add these together. And that's it. I've added those two matrices together. There's nothing more to it than that. So that should be enough for you to have a go at exercise 1. So the next thing to do is to go on to beginnings of matrix multiplication. I've just realised there's two exercise 1s, so it's the first exercise 1. I'll make sure they're labelled clearly. So the next section is matrix multiplication, but we are just going to do multiplying by a scalar. And I'm going to go through multiplying two matrices together in a live lesson because that's a bit more tricky. So a scalar is just a number. So if I want to multiply a matrix by a scalar, which is just a number, then all I'm going to do is multiply each entry in the matrix by the scalar, or by that number. Write that down please as an instruction or a definition, and then I'm going to show you an example. So pause the video to copy that down. So an example. If I wanted to multiply the matrix 0, 1, -1, -2, 4, 5 by 3, then I would literally just be multiplying every entry in this matrix by the scalar 3. So I'd have 0, -3, 12, 3, -6, 15. So to multiply a matrix by a scalar, you just multiply all of the numbers in the matrix by the scalar you're multiplying the matrix by. So that should be enough to do the next exercise 1. So all we've covered today then is very basic things. What is a matrix? How to add and subtract them, and how to multiply them by a scalar. I would like you to do the exercises I've put up and make sure you submit them on Show My Homework, please. And then in our next live lesson, we will probably carry on going through that paper, and then hopefully also getting on to matrix multiplication, where we're multiplying two matrices together. Okay. Any questions? Please ask me on Show My Homework.